on. Okay, so when you've got three unique things like B, A, T, these are our choices. By the time we get here, if we've got the B and A, that must be a T. If we've got the B and the T, that must be an A. And you can see why you have 6 choices and why it's 3 factorial, right? So there's a T, this one must be an A, and this one must be a B. So we have 6 different ways of arranging them. That's 3 factorial, and it gives us 6 ways, right? Don't chat now, this is not the time. If you're going to arrange these, you only have a choice between a B first and an O second. That's it, because there's nothing else there. If you have a B first, then this one could be an O, or it could be another B because there are 2 of them. If you have an O, then the next choice is going to have to be a B. You have no choice, right? And then for this one, you would have to have a B. For this one, you'd have to have an O. And for this one, you'd have to have a B. And suddenly we're down to 3 ways. So because there's repetition, there are far fewer ways that you can arrange that thing. So what we're going to do is we're going to work out the total number of ways to arrange them as if they were unique, and then we're going to remove the repetitions. Okay. So the way this works is this is going to be, so for repetition, you're going to always do total unique ways divided by repeats. By dividing, you're going to be removing them. So in other words, for that one over there, we have got 3 factorial ways that we can arrange 3 unique things. Because the B is repeated twice, that's 2 factorial, right? Those are the arrangements that you can get from just arranging those 2 B's. And we no longer care about the arrangements that we get from arranging B with B because they are the same arrangement, okay? And so this is going to end up as 3. Please note, so 3 factorial is 3 times 2 times 1. And so at the bottom you've got 2 times 1, so 3 is going to be left. There are 3 ways you can arrange them, and you can see that over here. Okay. So now with a more exciting example, because that one is so simple that it's actually almost hard to understand. The one that's inside your workbook that you need to now do is the word needless. So first of all, they say to you, how many distinct arrangements are there of the word needless? So the fact that there are 3 E's means that any time, if I start an arrangement with an E in the front, it won't make any difference if it's the first E or the second E or the third E, it's the same arrangement, right? So if I go and I just say 8 factorial, it's going to be wrong. The first thing I would do is I would write down that there are 3 E's and that there are 2 S's, and then I would write down what the other things are, because if you can't see what you're doing, things are going to go badly. And there are 8 letters in total. So if you, for example, don't see one of those E's and you say that there are 2 E's, everything is going to be wrong. If you leave out one of those letters, everything is going to be wrong. If they say they're 8, when you total up your things, make sure they're still 8. Okay? If they were unique, you would say that there are 8 factorial arrangements of them, right? And then you will divide by the number of repeats. There are 3 E's that are repeated. So those 3 E's, usually you'd be able to arrange them, if they were unique things, you'd be able to arrange them in 6 ways, relative to each other. But they're all the same. So there's just one way now, right? And those 2 S's, you would be able to arrange them in 2 ways, either the first S or the second S, or vice versa, for any position inside that number. So you just remove them. And that is going to be your answer. Please note that, well, just do it on your calculator. So if we had unique letters, spelling unique wrong, then we'd have 8 factorial ways of arranging them. That would be 40,320. Because some of them are repeated, that's greatly reduced the number of arrangements, right? Now try the second one that is on the same page. It says to you the number is 912193. First thing that you do is write down what's repeated so that you don't make any mistakes. So we've got 2 1s, 2 9s, and then we've got a 2 and a 3. So in total that's 6 numbers, right? And so you'd have 6 factorial if those 9s were not both 9s and those 1s were not both 1s, but they are. So you are going to remove 2 factorial and 2 factorial, the 2 that are repeated. Do you agree? and that's going to be 180. One other little thing I just want to show you over here. Please don't get silly. If you've got 5 factorial at the bottom here and you decide you're removing 3 factorial for whatever reason, the answer is not 2 factorial. Okay, this means 5 times 4 times 3 times 2 times 1. Okay, at the bottom this means 3 times 2 times 1. So that cancels with that, that cancels with that, that cancels with that, and what you have left is 20. So if you go and make that 2 factorial, it's going to be an unmitigated disaster. Do you understand? So please don't do that. Okay, good. Same thing as before, different 5-digit numbers. If they were all different, it would be 5 factorial. You have a duplicate of the 5, and there happens to be 2 of them. And so that is going to be 60 different ways, which you show your full method for and actually get a mark, right? Then for the next one, it says, how many of these 5-digit numbers start with an even digit and end with an odd digit? Generally speaking, these questions are small. There won't be 60 digits. So you can show the different things, and that is the easiest way to do it. So start with an even and end with an odd. So it's going to start with 2 and then either end with 5, or it's going to start with 2 and end with 3, right? That's starting with even and ending with an odd. Or it's going to start with 4 and end with 5, or it's going to start with 4 and end with 3, right? And those are the only 4 ways that you can meet that condition. Do you agree? There's nothing else. Now for each of these, we have 3 more spaces that we have to fill, and we have to decide how many ways we can fill these 3 spaces, right? So for the first one, if it starts with 2 and ends with 5, then the numbers that I have left are 3, 4, and 5. So I have 3 unique numbers. So I have 3 factorial ways that I can arrange those unique numbers, right? Which is 6 ways. So I can get a number that starts with 2 and ends with 5 with 6 different things in the middle, right? So we've got 6 ways of doing that, okay? For the next one, I have got a 3, and no, I have not got a 3. I've got a 4, and I've got 2 5s. So the number of ways that you can arrange a 4 and 2 5s is going to be 3 factorial over 2 factorial. Do you agree? Because the 5s are repeated, they'll give you the same arrangement. Okay? And that's 3 ways. So you can only get 3 ways. I can either get 2, 4, 5, 5, or I can get 2, 5, 4, 5, or I can get 2, 5, 5, 4. That's it. Can't get any other way. Then for the next one, when I've got 4 and 5, that means I have 2 and 3 and 5, right? So I'm going to, again, have 3 unique things that I can arrange. So that's 6 ways I can arrange that. And the last one, I'm going to have 2 and 5 and 5. So that's 3 factorial ways of arranging them if they were unique, but they're not. 2 repetitions, and that's going to be 3 ways. So in total, there are 18 ways you can arrange that thing. In fact, okay. So grouped objects. So the questions you're going to do today, the one exercise is about repetition, the other one is about group objects. They're testing the 2 separately, which will be nice. You won't have to do them at the same time. It says to you that you've got 6 friends. So this is the bottom of page 70. It says, how many ways can the 6 friends sit at the movie if John and Rachel want to sit together, right? Now, if they were 6 unique people that just wanted to sit together and they sat at random, you'd have 720 ways of them sitting if you have the 6 people and you arrange them, right? They're obviously all different people, okay? But now we've got 2 people that want to sit together. So what we do is we count John and Rachel as one person, and then we arrange everybody else around them, right? So if we have 6 people, it's now if John and Rachel are like one person, because they have to stay together, then we can move them between the other people and see how many arrangements we have, okay? So what you're going to do is you're going to write down that there are 5 factorial arrangements, because there are 5 ways that you could arrange John and Rachel as one person. Pretend they're one person, right? And the remaining 4 people. There are 5 ways you can arrange them, and then they're sitting next to each other, which is 120 ways. I'm missing something. What am I missing? So it's not 120. What's the answer? It's 120. times something. So if I'm going to say I'm going to arrange them, so I can pick them up, I can put them, they can be they can be first, or they can be second or third. I can arrange them, and I move them as a pair, so they're staying next to each other, which is what we want, right? But there's not just 120 arrangements, yes.
Depends which each John or Rachel.
Yeah, John or Rachel or John. That's a different arrangement every single time, right? So we are going to times this by 2. Okay. Or by 2 factorial, which is still 2. It's the same thing, right? So there are 240 arrangements. So what you have to do about this with this thing is you count them as a single object, and then we've got 5 unique objects, right, that we're arranging. But they can be either John and Rachel, or they can be Rachel and John. And obviously for all 120 ways, you could have John and Rachel, or you could have 120 ways and you could have Rachel and John, right? So there's going to be 240 arrangements in total. Okay. If you look at the next one, it says, how many ways are there if John and Rachel don't want to sit together? So now we want anything except this particular situation. Can you think of a quick way? We've got the total numbers of ways that you could, if you arrange the people at random, there's 720 ways that you can arrange them at random, right? There are 240 ways that you can arrange them together. How many ways can you arrange them so they're not together? Yeah. So this is what you try first. Some of these things are too complicated and you cannot just subtract. And there'll be good reasons why you can't just subtract, right? And you'll see them when we get further on. But this is the first thing that you try and do. You try and see if what they've given you is the opposite of what they asked for, right? So the opposite of them not sitting together is them sitting together. So therefore I can subtract it. Sometimes they're not opposites, and then you can't subtract them, right? But if they are opposites, if there's 240 ways they can sit together, then there are 480 ways that they can't sit together. For grouped objects, we count them as one thing. And then we work out the arrangements with them as one thing. And then we make sure we work out how many ways they can be arranged. So if you had 3 people out of these 6, right, and you wanted the 3 friends want to sit together, then you would say, okay, I'm going to count those 3 friends as being one person, and then I've still got another 3 people, so that's 4 people in total. So that would be 4 factorial arrangements with the 3 people sitting next to each other, and then there are 3 people. So I can arrange them in 6 different ways. They're 3 factorial. Does it make sense? So 3 factorial times 4 factorial, and you'll have all the ways. Ollie, you're looking